All right, key features of a polynomial function. Our learning target is I can identify. Key features of a polynomial. Okay. How to find the degree of a polynomial. In order to find the degree of a polynomial, you need a working pen. Hopefully this one works. The degree of a polynomial is the highest / largest exponent / power. For example, find the degree of the following polynomials. Looking at this guy right here, I've got all of these exponents right here, but which one is the highest, which one is the largest? 5 is by far the largest. So the degree is 5. Looking at this one right here, don't be fooled, even though this is my first term, 2 is not my highest degree because we have 4 and 3. So 4 is my highest. So my degree is 4. Awesome. Identify what the following solutions / roots are of the following polynomials. So I know looking at this one, I have a degree 2. So this guy is a degree 2, which means I'm going to have 2 solutions possible. So we can man this guy, pull out our, I'm going to move that, pull out this -6 to the side, so -6. My factors are going to be, we don't even have to worry about that -6 right now. My factors are 1 and 6, 2 and 3. Which one works out? Well, 2 and 3 are able to give me a -1 if I have a -3. 2 minus 3 gives me a -1. So I'm going to get x plus 2 times x minus 3. Finding my roots or my solutions, I set them equal to 0. So x plus 2 equals 0, and x minus 3 equals 0. So subtract 2 from both sides, I get x equals -2. Add 3 to both sides, I get x equals 3. So I know that these are my 2 roots, and it makes sense to have 2 of them because it was a degree 2. So with this one, we don't know how to factor this guy quite yet. But I know that I have a maximum degree of 3. I also have a 2 exponent here, but my degree is 3 because that's my highest. So this is a degree 3, which means I have 3 possible solutions. Okay. It's important to note the degree of a polynomial tells us how many possible roots / solutions / x-intercepts, we also call them x-intercepts, there are. All right, let's talk about a local max and a minimum. So functions have hills and valleys, which are called max and mins. And each polynomial may have multiple max and mins, depending on the degree of the polynomial. Okay. These max and mins are called our turning points. So our turning point, at each turning point of a polynomial function gives us a max or a min. What's important to know is the number of turning points is 1 less than the degree. So we say it's n minus 1, where n is the degree. We'll get into this a little bit later. Our n behavior, we're going to do a dance in class. So just write out 4 stick figures, and we'll do a dance in class. Okay. And then let's fill out this table really quickly. So this is just our n behavior table. A degree when the degree is even, and a leading coefficient when the leading coefficient is positive. Your graph is going to look something like this. Your n behavior is going to both end up at the top, and you're going to have a possible graph that might look like that. When your degree is even but negative, the n behavior is going to end all the way to the bottom, and you're going to have a possible graph that looks something like this. When your degree is odd and your coefficient is positive, then you're going to end up something like this. Start here, end here, and stuff is going to happen in the middle. When your degree is odd but negative, it's just going to be flipped. So we're going to start up here, end up here, and stuff is going to happen in the middle depending on our equation. So what is the n behavior for this top one right here? What n behavior is saying is as x approaches infinity, okay, as we get more and positive and positive and positive, where's my function going? Well, it's going up to infinity. So as x goes to infinity, f of x goes to infinity. As x goes to negative infinity, my function, which is f of x, is going up to infinity as well. So as x goes to negative infinity, f of x is going to negative infinity. All right, over here, as x goes to infinity, my function is going down to negative infinity. So as x goes to infinity, f of x goes to negative infinity. Same as x is going to negative infinity, my f of x is going down to negative infinity. So as x goes to infinity, f of x goes to negative infinity. For this one right here, when it's odd positive, when x is going to infinity, f of x is going up to positive infinity. So as x goes to infinity, f of x goes to positive infinity. When x is going to negative infinity, f of x goes down to negative infinity. As x goes to negative infinity, f of x goes to negative infinity. And our last one, as x is going to, if it's odd, negative, as x is going to infinity, my function is going down to negative infinity. As x goes to infinity, f of x goes to negative infinity. As x is going to negative infinity, f of x is going up to positive infinity. So as x is going to negative infinity, f of x is going up to positive infinity. We're going to do a dance about this in class. So